So over here we have three different classes, right? So there's actually some UML, this stuff over here, that describes the overall system. So overall, we're going to look at three different classes: maze tester, maze solver, and maze. So maze tester is just our main. So it's going to be a thing that loads up our main and then starts the recursive traverse method. Then we have maze solver, which is the actual implementation for traverse. And then we have maze, which is just a class that stores the maze information and provides a couple of helper methods. So over here, let's jump over to maze tester because that's where kind of the whole thing starts. So let's read through this. So this is our main method, right? Our starting point. So first thing we do is read in the name of a file, right? This is the file that's going to contain my maze data. And there's a few of these that the book contains. The one I use, right, is this one over here, right? This is a simple 5x5 map, right, with a couple of wrong turns that the algorithm can potentially take. So that's just test file.txt. So over here, have my prompt, right, to read in a maze file. Then I have over here, right, once I have the file name, is I actually go and actually load the data, right? So I create a maze object called labyrinth, and I call its constructor, and I give it the file name, right? So I tell it where to load that maze data from. This maze file is actually going to be identical to the one in the stacks linked stacks chapter, or linked stacks unit. Let's actually go and glance at it really quick. So over here, this is the maze class. The maze class has a few things in it. The main thing we're talking about right now is that it has a constructor that can load a file. So this is the constructor over here. The constructor, right, it passes in a file name. It goes ahead and creates a scanner object, right? So it has an object that will let it look inside and look at the data that file contains. And that scanner, right, is just being given a new file object, right? So the file object gets the file name, creates an object, right, that can get information from the file. We give that object to the scanner, which will then let us kind of read and write, mainly read information from that file kind of in an easy way. So we load up the file, we read the number of rows, read the number of columns, right? We need to know what is the size of that maze. Then we initialize our 2D array, right? So grid is going to be the variable, right, that contains our maze. So based on the rows and columns that we've read in, we create a new 2D array and store it into grid, right? And that's where all of our maze finding stuff will happen. So we load up that, and then we have this nested loop here, right? The nested loop is going to loop over every kind of row that you have from 0 to whatever the maximum number is, right? Essentially, it's going to be from 0 to 4 here, right? Because we have a 5x5 maze. So it goes from 0 to 4, number of rows, 0 to 4, number of columns. So the point is, it's going to go and it's going to read in all the different cells in there, right? It's going to read in every single number inside of this file. One by one, it'll read in each of these. Once it reads them in, it's going to individually put them into the grid, right, at whatever space they are supposed to be at. So once this is all executed, my 2D level data, right, my 2D maze data has been loaded into this local grid variable. The other things in here aren't that complicated. We have over here, right, try position, which is basically something that will mark a position as, oh, I visited or not, right? So that's relatively simple. Get and set, right, those are just our accessors. Mark path, this is going to be another kind of helper, right, that'll go to a specific place in the grid and then set it equal to 3, right, to represent that, oh, that's part of my path. The main useful ones here are going to be the valid position and toString. So valid position is something that the main algorithm will use to determine if it can move to a particular space. So you pass in a row and a column, right, someplace you want to go, and what it does is it checks to see whether that row and column are actually inside of the grid, right? Because maybe you try to move to someplace outside of it. Well, that's not valid, so don't let that happen, right? So this will check to make sure you're inside of a valid row, and then this over here is going to check to see whether you're inside of a valid column. So if these two checks are true, and see that they're all ended together, right? So they all have to be true. If those are all true, then that means that yes, you're inside of a valid space, right? You're checking for a space that's actually in the maze. Well, if you're looking at a valid space, then the real question is it free for me to move to, right? Is it not a wall, and is it not someplace I've visited? And that's what this line here is checking, right? So it's checking to see whether the grid at that particular point is equal to 1. And we said earlier, right, that 1 is the value that we give to a space that's not occupied by anything, right? It's open, and I haven't visited it yet, right? So that's a new place for me to see. The other magic numbers, right, were 2 and 3, where 2 represent that it was a place I had tried, and 3 represent that it was a place I had tried, and it was on my final path. All right, so if these two things work out, right, if I'm inside of the maze and I'm at a square I haven't seen before, then my result ends up being true. Otherwise, my result was initialized to false, so it'll end up returning false, right? So either true or false is returned based on whether or not that's a valid space that I'm free to step into. So it's a very kind of useful function that encapsulates the different values, right, that could be stored in the map at any given time. The last thing I have here is toString. So this method is just designed to print out my maze, right, my grid, in a user-friendly way. So I have a couple of nested loops here, right? I have, again, a loop for rows, a loop for columns, and I just go through and I print out, right? Well, okay, so what I'm doing here, right, is I have a string and I'm storing everything into it, and then in the end I'll print it out. But I'm going to go and I'm going to look at each space inside of my grid, find out what value is there, and end up displaying it, right? So I'll take this, I'm kind of just going to accumulate it in there, right? So it's result plus equal. So I'm going to visit each cell at a time, and I'm going to add whatever's in there, right? Whatever number or whatever symbol's in there into my result string. And I'll do that for every space in there, right? And so in the end, right, I'm going to end up doing this kind of for each row at a time, right? So row 0, I'll do all the columns, and then I'll also add into result the /n, right? The /n is just saying, okay, that's the end of a line, right? Go down to the next row. And then once I'm done, right, once I've looped through everything, I'll have a string in here, right, that has a 2D representation of my maze, and I'll be able to print it out so I can easily see what's going on in my program. So now we've looked at maze, let's jump back to maze tester. So maze tester, right, we said we've loaded up a maze. Okay, then the next thing we do, right, is we do the println, right? So that's going to give us the nice display of what's in the maze. So that's pretty straightforward. Then we create a maze solver object. And the maze solver object, it's pretty simple. The constructor doesn't really do anything. All it does is it takes in a maze object and then it stores it as a local parameter. Let's actually look over there for a second. So you can see over here, this is the constructor, and all it does, right, is it takes in a maze object and it stores it into the local variable there, right, the maze variable. So it knows kind of what maze it should be solving, right, what should it be analyzing. That's where we put in our data. So constructor is pretty simple, and then what starts kind of the actual problem, right? It starts this whole process is this solver.traverse00. So solver was the maze solver object. We gave it the maze we want to work with. So let's start the process, right? Let's do a .traverse of 00, right? So start traversing recursively from that first point. So we'll end up doing our traversal, right? And then at the end we print out everything. So let's go ahead and open up the maze solver for real, and let's look at the traverse method. So this is our traverse method. I think what I'll actually do is end up bringing back our trace from before, just so we can see what was going on here. So this is our trace from before. So initially, right, let's say we're calling trace of 00. Let's look at this trace method and see exactly what it's doing line by line. So the first thing it has is this done parameter, which is going to initialize to false. So this is a variable that's only going to be set equal to true when we actually get to the endpoint, right? So when I have an actual solution. So this is part of my base case checking, right? I want done to be true because then I can finish out. All right. So we have our done variable initialized, and I'm faced, right, with some cell, right? Initially it's 00. So the first thing I check is to see whether that's a valid position, right? Is it someplace I'm allowed to traverse to? Before I do anything else, right, I need to check its legality. So here, right, if it is true, then I'm going to end up doing this stuff. If it's false, then I don't do any of this, right? So if I can't move to that position, traverse just returns false to represent that I can't even use that. All right, so let's say it is a valid position, right? So in that case, I go inside the if statement. First thing I need to do, because this is a valid position and I'm trying to traverse it, is to mark it, right? So I'm going to go to the maze, I'm going to go .try position, right? So it's going to go to that 00, and it's going to put the 2 in there, right? So this line here corresponds to this over here, right? This 2 that I put into my maze, right? That's where I marked that I was going to visit that place, or I had visited that place. So this line does that there. So let's say I've marked it. Well, since this is a recursive method, one of the things I need to think about doing is checking to see, am I at my base case yet? So one of the base cases, right, is if we're at the end of the maze, right? Am I done yet? Well, the way I can do that is by looking at the current place I'm trying to traverse, right? I'm trying to traverse some position, right? Some row and column, right? I'm trying to enter some cell. Well, is the cell I just entered, right? I just tried it, right? I've marked it as number 2, meaning I just visited it. Is the position of it, right? Is the row in the column, is that equal to the edge of the maze, right? Is it equal to maze.rows minus 1? Is it equal to maze.columns minus 1, right? Is it equal to the endpoints? Well, if it is, right, if I have arrived at 4, 4, then done equal true, right? I don't need to do anything else, right? I've already reached the end. I don't need to do anything else. So that's kind of one base case there. And let's suppose, I guess, for a second that the done does equal to true there, right? So we skip the else branch. Instead, we jump down here. And over here, right, it says if done, right? If we succeeded, right? If we hit the base case, one of the base cases, if we did that, go ahead and mark the path. So this is where we actually put in the 3, right? So if you remember down here, right, when we were decollapsing things, right, we said, okay, hey, I have all these calls, right, and then one by one I was deleting them and writing an appropriate 3 in the little graph here. Well, if I get to the kind of the endpoint over here, right, where I have my traverse of 0, 0, and then my graph here, well, that's when I'm going to be essentially right here, right, where I've done will be equal to true because at some point, right, I found my way to the end. And I had, originally when I called traverse for 0, 0, I had marked it as, number 2 to represent that I visited. Well, over here at the end, right, once I'm done, right, I just have this traverse here, I'm going to actually go into that same space, and I'm going to replace that 2 with the 3, right, to represent that, hey, I actually passed through that position, right? So so that line there, right, this is the bit we simulated, right, when we went through and we marked each of these spaces with the number 3, right, to give us back the path that we had used. All right, so let's look back up here and take a look at kind of the rest of the stuff that goes on. So let's suppose we're not at the end. What happens? Well, this code here is going to control how we move through or how we explore the other parts of the graph. At this point in time, we know that we've taken a step into the graph, but we're not done yet, right? Hopefully we've taken a step that leads us one cell closer to the exit, but we're not actually at the exit yet. So what do? Well, we try to traverse an additional place, right? Additional cell, additional tile. So the first thing we do is we call traverse on down, right? So if you remember in this picture here, right, I was moving in a certain way, right? So initially I started at 0, 0, and then from 0, 0, right, I went down to 1, 0, right? I went down one space. And then from that space, right, I tried going down again, right, to 2, 0, right? That's essentially this call again, right? So I made this call twice, right? It moved me down first to 1, 0, then to 2, 0. Right, so this is kind of my first option, right? If I want to continue taking steps towards the exit point, the first place I'm going to try is going down. So over here I have my done variable, right? And my done variable, this thing, right, this method here, right, this thing only returns true if I make it to the end, right? So this line is kind of supposing, right, that it's saying, okay, if you take a step down, will you get to the end, right? Well, if you do get to the end by taking that step down, then done's going to be equal to true, right? Because that call, right, to that traverse, that thing will be returning true itself. So if it is, right, done gets set equal to true. We succeeded by taking a step down. Well, if that does happen, right, then none of these other things will run, right? We don't bother to check any of these other ones, right? We don't bother to go right, up, or left, right? We're just done, right? If that does work out for us. And then kind of the rest of the stuff happens, right, where we say, okay, yeah, I found my path, so I'm going to go ahead and mark that I used it, and so on. Otherwise, right, if this doesn't work out, if this returns false because taking a step down didn't lead to a path that gets us to an exit, then we'll try the other directions, right? So if we're not done, then we try traversing to the right. So take a step to the right, then recursively call yourself on that right-hand cell, see if you can get to the exit. If you can, then done's going to be equal to true, and then these other ones won't be run, and then you'll mark that spot as being 3, right, as being something that was a successful path to the exit. If it doesn't work out, then try the top, right? Go that direction, try traversing from there. If it works out, you'll end up marking it. Otherwise, you'll go down, you'll try left, right? So go down to left, try that. If it works, mark it. Otherwise, return, right? And if none of these work out, right, if all of these end up being false, then that means that there is no path from the cell you're currently traversing, for example, 0, 0, to the end, right? So this is literally saying, try going in any direction, or try going in every direction, and then, if any of them work out, then, we'll use that. Done will end up being true, and that'll kind of cascade down and say, oh yeah, I got a path from the beginning all the way to the end. So this is kind of an overview, right? We talked about the algorithm. We did a trace. One thing you might want to do is kind of run this and see how the output looks, right? See how it paths through different graphs.